Hello, welcome to how to solve this radical equation. X square minus 2 is equal to square root of x plus 2. Since this expression square root of x plus 2 is a radical, it must be greater than or equal to 0. And this expression x square minus 2 is equal to this expression. So this expression x square minus 2 must be greater than or equal to 0. This expression x square minus 2 must be greater than or equal to 0. And if we move this negative 2 to the right side, then x square must be greater than or equal to 2. This is a condition for the solutions of this equation. Now let's start by squaring both sides. X square minus 2, and we take square at the left side, is equal to square root of x plus 2, and we take square at the right side. Now according to algebraic identity, a minus b whole square is equal to a square minus 2ab plus b square. This x square minus 2 whole square is equal to x to the power 4 minus 4x square plus 4 is equal to, this square will be cancelled with this square root, and at right side left x plus 2. Now we move this x and this plus 2 to the left side. X to the power 4 minus 4x square, and we move this positive x to the left side, it becomes negative x plus this 4, and we move this plus 2 to the left side, it becomes negative 2 is equal to 0. Next, x to the power 4 minus 4x square minus x, and plus 4 minus 2 plus 2 is equal to 0. Next, from these two terms, x to the power 4 minus 4x square, we can factor out x square. X square times, in bracket left, x square minus 4. And from these two terms, minus x plus 2, we can factor out minus 1. Minus 1 times, in bracket left, x minus 2 is equal to 0. Now this 4 is equal to 2 square. So this expression x square minus 4 can be factorized according to the algebraic identity a square minus b square is equal to a plus b times a minus b x square, and according to this identity, this x square minus 4 is equal to x plus 2 times x minus 2 minus 1 times x minus 2 is equal to 0. Next, this expression x minus 2 is common. So we can factor out this expression x minus 2. X minus 2 times, in bracket left, this x square times x plus 2 and this minus 1. X square times x plus 2 minus 1 is equal to 0. Now from here, either this expression x minus 2 is equal to 0, or this expression x square times x plus 2 minus 1 is equal to 0. From here, x is equal to 2. This is the first solution of this equation. Now to find other solutions, we solve this one. We multiply this x square by this x and this plus 2. X square times x, x cube, and x square times plus 2 plus 2x square minus 1 is equal to 0. Now to solve this cubic equation, we split this 2x square into 1x square plus 1x square. X cube plus x square plus x square minus 1 is equal to 0. And from these two terms, x cube plus x square, we can factor out x square. X square times, in bracket left, x plus 1, and we use here parenthesis x square minus 1. And this plus sign will come here, plus, and we can consider this one as 1 square. Now this expression x square minus 1 square, according to this algebraic identity, a square minus b square is equal to a plus b times a minus b, is equal to x plus 1 times x minus 1 is equal to 0. So you can see that this x plus 1 is a common factor. So we can factor out this x plus 1. X plus 1 times, in bracket left, this x square and this x minus 1. X square plus x minus 1 is equal to 0. Now from here, either this expression x plus 1 is equal to 0, or this expression x square plus x minus 1 is equal to 0. From here, x is equal to negative 1. This is the second solution for this equation. Now we solve this one. This is a quadratic equation and can be solved by quadratic formula. In this equation, a is equal to 1 and b is equal to 1 and c is equal to negative 1, and quadratic formula is x is equal to minus b plus minus square root of b square minus 4ac divided by 2a. In this equation, we put the values of a, b and c. X is equal to minus value of b is 1 plus minus square root of b square, we put the value of b 1 square minus 4 times value of a 1 times the value of c negative 1 divided by 2 times the value of a 1. Next, x is equal to minus 1 plus minus square root of 1 square is equal to 1 and minus 4 times 1 times negative 1 plus 4 divided by 2 times 1, 2. Next, x is equal to minus 1 plus minus square root of 1 plus 4, 5 divided by 2. So from here we have two values of x. X is equal to minus 1 plus square root of 5 over 2, and x is equal to minus 1 minus square root of 5 over 2. This is the third value of x and this is the fourth value of x, and the other two values of x are x1 is equal to 2 and x2 is equal to minus 1. The value of x1 is equal to 2, value of x2 is equal to minus 1. So these are the four values of x. Now because we have solved a radical equation, so we must verify these solutions. We can verify these solutions by two methods. The one is by putting these values in the original equation, and the second method is checking of the solution in this condition: x square is greater than or equal to 2. The condition is x square must be greater than or equal to 2. First we check the first value of x, 2. Here we put the value of x, 2. 2 square must be greater than or equal to 2. 2 square is 4, and 4 is greater than or equal to 2. You can see that 4 is greater than 2. So this solution is a valid solution. Now we check this second solution. The second solution is x2 is equal to -1. Here we put the value of x, -1. -1 square is greater than or equal to 2. -1 square is 1 is greater than or equal to 2. You can see that 1 is not greater than or equal to 2. So this solution will be rejected. Now we check the third one, that is -1 plus square root of 5 over 2. In place of this x we put this value. We can write this -1 plus square root of 5 over 2 as square root of 5 minus 1 over 2. We take square of it because here we have x square is greater than or equal to 2. Now according to algebraic identity, a minus b whole square is equal to a square minus 2ab plus b square. This square root of 5 minus 1 whole square is equal to square root of 5 square minus 2 times square root of 5 times 1 plus 1 square divided by square of this 2 is 4 is greater than or equal to 2. In the next step, this square will be cancelled with this square root, and here left 5, and this plus 1 square is equal to plus 1 minus this minus comes here. 2 times square root of 5 times 1 is 2 times square root of 5 divided by 4 is greater than or equal to 2. 5 plus 1 is 6 minus 2 times square root of 5 over 4 is greater than or equal to 2. Now we can factor out 2 from here. 2 times in bracket left 3 minus square root of 5 over 4 is greater than or equal to 2. From here 2 one time and 2 times 4, and here left 3 minus square root of 5 over 2 is greater than or equal to 2. You can see that this 3 minus square root of 5 over 2 is not greater than or equal to 2. So this condition is false. The third solution is not a solution. We reject this one. Now we check this fourth one. Now in place of this x we put the value of x4, -1 minus square root of 5 over 2. The value of x4 is minus 1 minus square root of 5 over 2, and we take a square of this because here we have x square is greater than or equal to 2. Next, According to this algebraic identity, a minus b whole square is equal to a square minus 2ab plus b square. This negative 1 minus square root of 5 whole square is equal to negative 1 square minus 2 times negative 1 times square root of 5 plus square root of 5 square divided by square of this 2 is 4, and this expression is greater than or equal to 2. Next, negative 1 square is equal to 1, and minus 2 times minus 1 is positive 2, and positive 2 times square root of 5 plus 2 times square root of 5 plus this square will be cancelled with this square root, and here left 5 divided by 4, and this expression is greater than or equal to 2. Next, this 1 plus this 5, 6 plus 2 times square root of 5 divided by 4 is greater than or equal to 2. Next, from here we can factor out 2. 2 times in bracket left 3 plus square root of 5 over 4 is greater than or equal to 2. Now from here 2 1 time and 2 2 times 4, and here left 3 plus square root of 5 over 2 is greater than or equal to 2. Now you can see that 3 plus square root of 5 over 2 is greater than 2. So this condition is true. So this solution minus 1 minus square root of 5 over 2 is also a valid solution.